Hi students, this is Saranya, Assistant Professor, Department of Mathematics, Dr. NGR Educational Research Institute. In this video, we are going to discuss about the chapter Automata. The one of the topic we have to see Turing machine. Turing. Now we are moving on the introduction. Turing machine. Turing machine automata or theory of competition. One of the subtopic is Turing machine we have to discuss. There is a much more powerful model of competition called in the Turing machine. The Turing machine is a shortly we have to take TM. It is the first proposed by the Alan Turing in 1936. Alan Turing. Alan Turing. He's a British mathematician. The Turing machine was invented by the Alan Turing in 1936. It is used to accept the recursive enumerable language. Turing machine is a fundamental concept in the theory of computation and playing the important role in the field of computer science. They were the first described by the mathematician and the computer scientist. The Alan Turing in 1936 was and provide the mathematical model of simple abstract computer. In the context of the automata theory and theory of competition, this machine used to study to the properties of algorithm and to determine what the problem cannot be solved in a computer. They provide the way to model to behavior of algorithm and to analyze their computational and then complex, which is the amount of the memory they require to solve the problem. Next. Turing machine's behavior is determined the finite state machine which consists determine the finite state machine consists a finite set of states, a transition function that define the action to be taken based on the current state and the symbol being a read, a set of start accept state. Turing machine began in a start state and perform the action specified by the transition function until it reaches accept or reject state. If it is a reach accept state, now the competition considered as successful. If it reach reject state, now the competition is considered unsuccessful. Turing machine are an important tool for studying of limit of computations and for understanding the foundation of computer science. They provide a simple yet powerful model of computation that has been the wide used in research, has had a profound impact on our understanding of algorithm and competition. Turing machine is similar a finite automaton, but a Turing machine has an unlimited memory. You have in an unlimited, infinite number of symbol confined. Turing machine is a much more accurate model of the general purpose of computer. Turing machine can do everything that a real computer can do. Even a Turing machine cannot solve that certain problems. Such problems are beyond the theoretical limit of competition. Turing machine consists of a finite control, a tape, and a head that can be used for reading or writing on the tape. Turing machine is not simply one more class of automata. It may replaced later by a yet more powerful type. Any augmented Turing machine, multi-tape, random access machine are not stronger in terms of computing the power, the basic Turing machine. Any augmented Turing machine can be converted into simple basic Turing machine. So, the Turing machine seem to form a stable and maximal class of computational device. In terms of computational, they can perform Turing machine consists of a tape is infinite length, which is a read and write the operation is performed. Tape consists a infinite cell on which each cell either containing input cell or a special symbol called a blank. Input symbol A, B, 0, 1, and so on. And blank symbol any shape. B or capital B, B for blank, and some symbol like or star, anything you have to specify special symbol you can give. It is also consists a head pointer which point to cell the currently being a read, and it can move in both directions, left or right. So this is some example of the Turing machine infinite length, infinite state. So we have using some strings are there, 0, 1, and a blank symbol. This is a special symbol. This is special symbol. You have one header. That header is you have one finite controller. This is your finite controller. So that's why you said Turing machine model uses infinite tape, unlimited memory. You have in unlimited memory. The tape head read or write. Once it is read now, again they have to do this process. It is a halt or not, you have to check it. Once it is accepted now, okay, symbol on symbols of the tape, the tape head can move left to right. Tape will be moving left to right. Turing machine computation. So what are the computation we have to using now? Computation. Read, write, start, leftmost position on the tape. Input string written the leftmost in square of the tape, rest is blank. The computational proceed according to the transition function. Given current state of machine, a current symbol being a read the machine. Transition is a new state. Q0 to Q1 is a new state. The write the symbol of the current positions, overwriting existing the symbol. The moves the tape head left or right. The computational end, if and when it enter, they either accept or rejected in the state. And we have to see in last. One kind of the problem we have to discuss. That problem will be accepted or not. Now, coming to that, to what we have to see in here first now, what is Turing machine? Formal definition Turing machine, design Turing machine, universal Turing machine, church Turing machine thesis. So first you know about that what is Turing machine, formal definitions and designing of Turing machine. That language, one language you have to given. With the help of the language, we can frame the tape. Uh, in your syllabus you have not doing the universal Turing machines and church Turing thesis, only have in a seeing a Turing machine. That is undesirable. What is Turing machine? Turing machine is a theoretical model and competition that can be implemented by the hardware or software. It is conceived an abstract machine that can be one of a finite number of states. Machine is only one state at a time. It can be changed from one state to another when triggered in some input. Turing machine is Turing machine is defined by the list of the states. It is the initial state, the input that triggered each transition, and the action that machine takes on each inputs. This is Turing machine. This is simply how to understand. Uh, First, you know about that finite state machine. After finite state machine is most powerful than the PDA. That both finite state machine and push-down automata is a very most powerful than Turing machines. The finite state machine for in a regular languages. Push-down automata is a context-free languages. Turning machine is a enumerable, recursively enumerable, other turning in a recognizable in languages. Now let us see one by one. Now let us we whatever in the data structure we had in an infinite state machine push down automata. Let us see what is the kind of the data structure that we will have in a Turing machine. So if you remember in this case our the finite state machine, except the regular languages, except see, See, this is for the finite state machine and push down automata. Our finite state machine, which accept the regular language data structure, we had a only the input string, only having a in this, these are all in a strings, only the input strings, just had an, a controller that which can one direction, which can move in one direction, that is forward only. So we saw the finite state machine, so saw the FSM, that he had very limited power and also a very limited memory, and the class of languages is accepted by the finite state machine and regular languages. Finite state machine and regular languages. And we already saw what are those regular languages. Coming to the push down automata, that is a reader of data structure. See that the push down automata is a reader of data structure. That we had was input string. You have an input string, and a part input string we had on a stack variable, stacks or there stacks. So what made push down automata different from the FSM? In the finite state machine was presence of a stack. So because of the presence in the sticks, we saw that push down automata was most powerful than push down automata is most powerful than finite state machine. It's very most powerful than finite state machine. And then class of languages that accept, which is known as a context free. What we have to read as a context context free languages. So push down automata is a construct free languages, and the higher class of languages. um, Comparing the regular languages, so this in this diagram represent the input string and also represent the input string and also the stack, which add the more power in the push down automata, making it different from the finite state machine. Now coming down, we have in a Turing machine, we are going to discuss, we are going in this lecture, in Turing machine, the data structure, that we have something known the tape. The tape something look like as it is shown in the in this, shown in this already we have to show diagram. No, this is a Turing machine diagram. Turing machine diagram, we see the tape of the sequence. Infinite symbols are there, infinite sequence. Over then we have something known the tape header. This is your header. So the tape head in position on the symbol, which is a current controller, is present, and then the tape head. It can either move one step left, or another step is one step is left, another step is either left or right, depending on the kind of competition we have. Then we have input symbol. As told you, this infinite sequence of the input symbol that we have filled into the all these cells, and then remaining cells, instead of leaving just a blank, remaining cell instead of leaving a blank, we fill them with a special kind of the symbol that is known as a blank symbol. If you see here, we have a tape alphabet which is represented by the sigma. You know the sigma is used to represent the input symbol, this trading this. From beginning in the lecture series, the tape alphabet, it contain a 0, 1, or A, B means blank, any kind of the symbol. And then as I told you, blank symbol is a special symbol. This is a blank symbol. Blank symbol is a special symbol. It does not belonging the sigma. The blank symbol does not belonging sigma. means a blank symbol is not part of the tape alphabet, or it is not part of the input symbol. But what it just in a special symbol that is used to fill the infinite tape. So as we are living in the infinite tape, the blank or empty cell, one filled with the special symbol known as in the blank symbol represented by this blank symbol is represented by. So this is a basic data structure that we have our in a Turing machine. So the main thing that you need to remember, the tape is infinite sequence on the, and then the tape head is positioned and the current controller is present, and then empty cell is filled in a special known as a blank symbol. Now let us look like the going to the problems on basic problems. These are all the definition. This is a definitions for a Turing machine. Seven tuples you have: q, summation, tau, delta, q naught. This is a special symbol f. We are all finite set of q and the summation sigma tau are all the finite. The q is a finite state. Summation is a input alphabet containing blank symbol. Tau is a tape alphabet, that is the tau, blank symbol belonging to tau. The tau is contained in a sigma, that is a sigma. So delta is a mapping, transition mapping, depending on presence state to present state alphabet, a point by the head pointer, it will be move in a new state, the change the tape symbol. So may or may not the move a head pointer in either left or right. A Q naught is a starting initial state. This is a special symbol is a blank symbol called it as, you can call it as. F is a set of all finite state. Now we are coming to the problem. Before going to the problem, what is they're giving the languages. They're giving the languages. What is a Turing machine language is given a simple problem. A power n, b power n, n is greater than or equal to 1. So this is what now that is a given languages. This is your given language. Before going to proceed the problem, first I give what are the procedure we have to followed in this languages, this tape Turing machine. So first I give everything in a descriptions. So M is replaced by leftmost A by X. We can encounter the A by X. Okay, now and move to the right leftmost. You can B, you can concentrating B, you can replacing by Y. So M moves left to find the rightmost X and moves one cell right to leftmost A and repeat the cell. While searching for B, if a blank encounter, M halts are not accepting without accepting. Not accepting, it is M is a halt. It does not anything moving. After changing B to Y, if M find no more A's and then M check no more B's remaining now, then accept the string. Otherwise not. No more A, no more B now, M will be accepting. Otherwise it is not accepted. Tape Turing machine. Now we proceed the problem. I give one problem. This is a definition. Already we discussed this definition. Turing machine having a 7 tuples: q, sigma, tau, delta, q naught. This is special symbol f. What are this? You know that. Now I'm going to the step 3. Step 3 is a problem. So see, given Turing machine, say what they have to take, that is a language, given languages. That languages na L means languages. A number of A's should be exactly to the number of B's followed by A's. Number of A should be exactly to the number of B's followed by A's. Then L is equal to, how to get the strings now, like that. When I put N is equal to 1, you are getting A, B only. N is equal to 2, 2 A's, 2 B's. N is equal to 3, 3 A's, 3 B's. N is equal to 4, 4 A's, 4 B's, up to so on. Now myself, I have to choosing any one of that languages. That is a 2A, 2B I am choosing. This is a tape. I can frame the tape. So inside you have in a symbol. So what are the symbol strings you have to put? A, B, B, and remaining you have to put it in a blank. Okay, then now first what we have to consider now, see already we have to given everything in a, given the description. So what is the given? M is replace a leftmost A by X, it moves rightmost right to the leftmost B by replacing by Y. M moves left to right, most X moves one cell right to leftmost A, repeating the cells. So that's procedure we have to follow in this problem. See guys, the first I am choosing the leftmost A. Leftmost A, na, that is a starting A, that A you can encounter. So you can A replacing A by X, that is for header. What is a controller? This everything user can defining the tape. Only this problem, this Turing machine, this tape user can define. Only user can defining. Whatever you have to assumption, you can take that user can define. You can encounter the A, first A, leftmost A, that is initial state, that is q naught. Q naught you can replacing by A now, you have to take it as X, that only giving in the next so what is a replacing here? X. A is a encounter, A X encountered by the X, so we have to replace it, and remaining terms you have to return. So what is where it moving? It moving on the, it moving on a q1, q1 state to, it could be reach as q naught to q1 state. That is q1. Again you can come to the here 1a now, you can move on that, that is a rightmost A. 1 1 A 1 1 X you can check. So what you have to getting here? Q1 comma A, that is q1 comma A in R, so it is as it is, we don't save anything. Next, next, what is a next leftmost B, we coming to the next leftmost B, that is a q1. Already you have to replace encounter A, again you have to check that value, and coming to that again B, the q1 comma B, that is what? Q1. Q1 state, you have to q2, that is a B na, you can encounter the B, encountering the B by Y, encountering the B by Y. So what is you have to get? That is also the leftmost, the nearest to the leftmost you can choose. And then coming to that, what is your what is the transition function delta? Q1 comma B is Q2 comma Y comma L. Then next again we have to coming to Q1 state 2, you can reach to Q2. Yeah, Q1 state to Q2. So again you have one, again one A. You can encounter again this A by X. So this is what another one, rightmost after the leftmost, that Q2. That Q2 is what? Q2 comma A transition function moving on Q2 comma A comma L. This is a self loop. Again you getting that loop, this transition. See, next again you have to coming to that, again the first one, first X. We have to check if it is already that that X will be in a readers. You can encounter the A by X. So already we have to again checking that any other possible now. Once altered now, we have to change anything. It is altered, it's offer. So Q2 in a X only itself. So we want to change. So that is what again Q2 comma X where transaction, again a transaction to the Q0 comma X comma our right side, it will be moving. X is a reading, already reader, X will be already reader. So first iteration is completed. Now moving the second iteration. Second iteration, again we start the iteration starting itself. So what is a first iteration is completed, how you completed the, again you start the X, again coming to that A, another A will be there, that A you have to encounter, that A you have to encounter by the X. Again we have to start in a Q naught. What is the stating? If you extend already Q, why we are using a Q naught, Q1, a Q3 now? A and B only itself only now. So that's why we have to take in a Q naught, Q1. If you extended, na, string will be in elaborated. That image in the transition diagram should be in elaborated very big. So that's why we have to take it has in a self loop again only A itself. So that again A will be replaced by X itself only. So that's why we have to Q naught, the transition Q naught comma A where it transform. Again it could be transferred to the rightmost cell Q1 comma X comma R, right words, right word. So the again you can replace that X. Again coming to that b, that b is also an already know that that is b is q1. That q1 na, the delta, the transition of q1 comma y, where it transform, again write q1 y comma r, again q1 y comma r. So you can replace, so we doesn't have. Then next again we coming to that, x is replaced, a is replaced x by x, you have to getting a 2x, we doesn't have any changes. And then y, that y you have to again it have getting the self loop q1, that q1 have in a b, that q1 comma b la you have to check, q1 comma b where it moving, again left, it q2 comma y comma l, it moving on q2 comma y comma l, q2 comma y comma l na. So that again you have to coming to the l, this is your l na. So that b you have to replace by y, so that is q2 comma y, you have to getting q2 comma y comma l ne, you have to replace it, that transition where it going, q2 comma y comma l. Then next after that x, see here that, then coming to the x again, that is what in a, that is a q2, that q2 will be transaction to the q2 comma x, anything changes, no, again you have to getting the q2 q0 comma x comma r. Therefore the second iteration is completed. If it is any changes now, the string will be accepted now, we doesn't, that is successful. It is not accepting now, it is rejected means it is unsuccessful. So now here x is again you are coming to the stage x na, x is already read, x is already read, second iteration is completed. Again to the leftmost, again we start the hydrations. Next next most, what is the next most, again coming to the x na, after that y, leftmost you come, q naught comma y, it could be moving that q3, why we are moving to the q3 na, we have to check any other changes will occurring or no, it is a q naught comma y comma r, that is q naught. Then again coming to that y, rightmost you have to coming q3, that is what q3, that q3 q naught comma y will be in a q3 comma y comma r, that q3 na, it moving on the delta mapping q3 comma y in a q4, it could be transaction, here only have one transaction will be happen. Now, if a transaction will be happen na, that Q3 will be move on the blank, blank tape. What is in that blank symbol? The symbol, both the symbol is a blank. That is your header. That header in a, and then controller. That is a Q4 you have in a controller. That Q4 comma blank na, where it moving? Q4 in a blank comma right. Right most it will be moving. Then if then after that string will be accepted, we have not any other moving, so string is accepted. Why it is string is accepted? See, q3 comma y, q4 comma y comma or everything will be in halt, so everything will be halt, everything will be accepted, all the a's and all the b's, a by x, b by y, a. Then q4 you can again coming to the blank, then the blank space now, state of the transaction diagram, if some that q1 that blank space will be also accepted, the blank also you can finally check, that is also we have doesn't any other halt moving there, any other values, so that's why the string is accepted. Now coming to this is for the transition table, input symbol a b x y, and then already find na xy, and a blank symbol, straight is q0 q1 q2 q4, q4 is a blank symbol. So how to get na delta q0 comma a na q1 x comma r, so we have to discuss na in the beginning itself, the first iteration. See here q0 comma q0 comma a is q1 comma x comma r, q1 comma b is q2 comma y, q2 comma a, q2 comma al, this one we have to corresponding value, you can fill it over the corresponding rows. Then after with the help of the table we can frame the diagram. States, this is for initial state, q0 is initial state, it reach the first transaction going on a, you can replace by x by r, transaction is q1. Then again what we have to take, rightmost cell a will be there, That again you can replace y, that q1 again reach to your one self loop y comma r. How you have to find the self loop? See here, self loop q1, that q1 comma y in q1 comma r, again q1 comma b, q2 of y comma l. So that's why we have to putting there in this diagram. So we have in the self loop will be there. Again, it could be in reach, again concentrating on a B here, B by Y here, in leftmost cell, that is reaching to the Q naught. Q naught you have again Y comma L self loop. That self loop A comma L na, A comma L will be remaining. Then again that one Q2 to Q naught it come. That is you can replace again the second iteration x a by x comma, or already one x will be there. Again one a will be, you can change the leftmost cell and the. So then after that Q naught again reaching to the Q3, that is y comma rightmost cell B you can replace. That B again replacing going to the Q4. Q4 is a blank cell. We doesn't have moving any left to right, right to left, left to right. So this is a double ring na, double nodes na, that nodes in the final state. The final state is what, blank will be rightmost cell, rightmost symbol. That's all about this problems. This is a diagram table, and this is a diagram above problem. uh, this is remarks na, the non-deterministic Turing machine, there can be more than one possible move for a given state and the tape symbol, but non-deterministic Turing machine does not add by any power. Every non-deterministic Turing machine can be converted into deterministic Turing machine. The multi-tape of Turing machine, they can be more than one tape and head pointers, but does not add any power of Turing machine. Every multi-tape can be converted into the single tape Turing machine. Now we can change any multi-taper can be converted into the single tape machine. That's all. I hope you're all enjoying this section. Thank you. Thank you all.